All right, I think we have our quorum. Well, howdy out there, wonderful folks. My name is Neil, and I want to thank you all for joining me today on this webinar. And why are we here today? Why are you here today? Well, probably for one of these reasons. You're here to learn the basics of storage, whether you're new to storage, you're a network admin looking to learn more about storage, or a system admin who wants to learn more about storage concepts. Maybe you want to understand the differences between storage media, like disk versus flash, or between storage protocols, NFS, iSCSI, fiber channels. So perhaps you're here to understand better approaches to troubleshooting, monitoring, and tuning. And you might be here for how storage relates to security and to learn about solutions that you can rely on during any kind of cyber recovery scenario. Feel free to use the chat and Q&A to ask questions. And if we have time today, we'll get to the answers towards the end of the presentation. So my name is Neil Kassal. I've spent 21 years working with storage technologies, 29 in IT. I've worked for PayPal, Wyndham Hotels, America West Airlines, which later became US Airways, and then American. I've been employed by Fusion IO, Nimble Storage, and Dell EMC. I'm certified with NetApp, with Pure Storage, Nutanix, and TinTree, the old IntelliFlash technology. And I'm a VMware triple VCP, and I have 17 years of experience with VMware storage integration. And storage is important for business, but it's also, to me, kind of fun. It's some cool toys. So I like classic 80s arcade games. And the idea of, storage technologies that receive requests and then, satisfy those requests, reads, writes, et cetera, kind of reminded me of the old game Tapper or Root Beer Tapper. And you serve customers in an increasingly busy and super parallel environment. So it's kind of similar to what storage arrays and subsystems do, which is, record and preserve things quickly in a conceptually ordered fashion. So growing up, I had a Commodore Amiga 500 personal computer. And data storage protects your information, and it's vital for data integrity, cyber resiliency, and disaster recovery. And it kind of reminded me of the old video game I had in my Amiga, Arkanoid, because data storage is the practice of kind of fighting off entropy, whether it's physical disk failures, bad actors, or a natural disaster. And I like cars, and I also like motorcycles. And sometimes storage is about performance, just like automobiles or motorcycles. So playing around with some of the AI image generation tools kind of gave me some ideas about how to help visualize these concepts and educate folk about it. So back in 1999, I saw the movie The Matrix in Indiana, and right when it first came out, and I was blown away. And, in the world of the Matrix, ones and zeros represented all the shared world that the people lived in, and that was the reality that most people knew in that movie. And so similarly, today, at the core of all the digital technology out there, your phone, your computer, everything is just a string of zeros and ones, bits. And those represent things. Those represent, text or images, videos, anything conceivable, databases, etc. So to understand how they can zeros and ones represent, more complex things that you're more familiar with, right? A file, a video, etc. Let's take a file called pets.txt, and that contains 3 letters in it, right? The word dog, D-O-G. And normally that would take, about 3 bytes worth of storage, right? Or 24 bits, 24 zeros and ones worth of data. So at the core of all technology, everything is just a string of zeros and ones, and you can represent other objects and concepts with that. So let's talk about block versus file. I drive a 21-year-old car, and it does break occasionally, but I really enjoy fixing it myself. So I'm no stranger to automotive parts stores. And in keeping with that theme, the block versus file analogy is kind of best served with a virtual visit here to the local auto parts store. And for those who don't know, if you've never been to an auto parts store, there's something called a core deposit. And that's basically a little deposit or price you pay that's refunded to you when you bring back, a broken part after you've replaced it with the good part that, the auto parts store sells you. And then for those, in Washington and Oregon, it's similar to paying a deposit on your soda can, right? So it's a deposit on an auto part, core deposit. Let's talk about file access. Let's talk about file storage and what a read kind of looks like with files. So let's take a look at getting a new automotive starter, at this auto parts store. So we got Bob on the left, and he's an auto parts worker, and Rick is the customer. He's the guy on the right, and he needs a starter. And this can be thought of as a read request from an application, Rick coming in and asking for a starter. So Rick doesn't know exactly where the starter is in the store, and he can't go behind the counter. He's the customer, right? And Rick has to ask Bob to get that part, find it and retrieve it for him. So Bob goes and gets that starter and he returns it to Rick. And that's similar to a read request being returned back to the application. And so let's talk about a second scenario, still talking about file access. This time it's a write. So let's say Rick just worked on his alternator. He already went into the auto parts store and he replaced his alternator with a new one. And write access is kind of like Rick returning his old alternator to the counter to get his core deposit back. So Rick doesn't know where the alternator needs to go, nor, again, can he go behind the counter. So Rick asks Bob to return the alternator for him. Bob takes that alternator to be refurbished and then later, resold, and returns that deposit to Rick. So that is a write. That's kind of like a write scenario where, Rick is bringing something in and it needs to be written back to the, the shelves in the back of the store. So that's file access. Now let's look at block access. Block access is better understood by looking at things from Bob's point of view, the counter worker. So let's talk about reads, and let's talk about that getting a new starter scenario. So block at read access is like Bob's job behind the counter after Rick asks for a starter. Bob can look up where the starter is among all the shelves, and he can go find it, and then he brings the starter back to Rick. And Bob finding that starter is the equivalent of a block read on the back end of a storage system. Okay. And writes in the same scenario. Let's review. Rick just returned that alternator to get his core deposit back, from Bob. And so the block write access is like Bob's job, behind the counter when Rick gives him the alternator, to place back there. Bob has to look up where the alternator goes for refurbishment among all these shelves and go put the alternator there. And then he can go refund Rick's core deposit. So let's talk about file systems. So if the auto parts are periodically rearranged in the store, the records or an internal catalog at the store needs to be updated. And that's what a file system is. That's a record of where the files actually physically sit over a series of blocks on storage technologies. And in this analogy, the blocks are like the little cubby holes where all the parts sit, whether it's, the starter that Rick came in to get, or whether it's the alternator that he returned that's going to be refurbished and resold. So only Bob needs to know about where the parts are. Rick doesn't. Rick doesn't need to know because he's a file system client. Whereas Bob is managing a series of blocks and he's using block access to retrieve those files. So the back part of the store can have space added or taken away, and it doesn't matter to Rick, but it does to Bob. So that's a key difference between block and file access. There's more overhead or work needed to manage the block system. And so Bob's job as a counter worker is kind of harder than Rick's as the customer. And that's the key take home here is when you access things via file, it's less work on your clients. It's more work on the back end. It's more work on the block side of things. So do you remember the size of your first hard drive? Do you remember the size of the first digital media player you had? So my first hard drive on my Commodore Amiga 500 was 52 megabytes, not gigabytes, megabytes. And I remember that seemed huge at the time. And my first digital media player was a Diamond Rio, and it had a 32 megabyte smart media card in it. So what is a hard drive and what's a solid state drive? Well, a hard drive is a computer component that stores and retrieves data using magnetic storage. So hard drives are non-volatile storage devices, meaning they can retain data even when the power isn't being supplied. So you can turn off your computer and the data stays there. So I often refer to hard drives as spinning rust because historically, iron oxides were applied to the platters to record the magnetic information that represents those digital bit streams, those zeros and ones. And a worker in an auto parts store is like the arm of a hard drive, in that if they're in one area retrieving a part, it takes time for them to move through the store and travel to another area to get another part. So that's called latency or access time. And in a hard drive, that latency is usually around 10 milliseconds, give or take a few milliseconds, depending on the speed of the hard drive and whatnot, but it's about 10 milliseconds. A solid state drive is a storage device that uses typically NAND flash memory to store data. So SSDs are a newer type of storage device that's replaced traditional hard drives in computers, servers, and storage arrays. So in this auto parts store analogy, if you could teleport between the shelves almost instantaneously to retrieve different parts, that speed, the lack of latency, is how SSDs compare to hard drives. So they're obviously way faster. When you could teleport, you wouldn't have to walk between shelves. Of course, that would make you faster. So latencies of a solid state drive are typically under a millisecond, and oftentimes they're measured in hundreds of microseconds. So really fast compared for latencies compared to hard drives. And one important thing to note is that you can gang together hard drives and get a lot of bandwidth, but there's no such thing as a hard drive that's going to have latencies as close to flash. So flash is going to beat hard drives every time for latency, for performance on latencies and access times. Okay, so this is a hierarchy of storage technology and latencies. And so CPU registers have the smallest amount of capacity, but the lowest latency. That's inside your CPU. And then the cache is also inside your CPU. That has a little bit more latency, but it's a bigger capacity in the registers. And then your memory has a little bit more latency than the cache, but higher capacity. And all of those are volatile, meaning if you switch off your computer or your server, the contents of the CPU, the memory go away. So those are all volatile storage technologies. And so of the persistent storage technologies, flash is faster than hard drives, but until recently, the capacity of the flash drives was typically smaller than magnetic drives you could get, traditional hard drives. Nowadays, that's not the case. So single SSDs can now be bigger than the biggest single hard drives, and they're smaller as well. So they take up less power, and they have higher density, per unit volume. And there's something called persistent memory, or PMEM, on this chart. And that's, any kind of technology like the now abandoned Optane technology from Intel and Micron. And there's some future technologies on the horizon that are also considered persistent memory. And those split the difference between, capacity density and access speed. So they have access speeds closer to DRAM, dynamic random access memory, but they have larger capacities as well. So they kind of slot in between, flash and non-persistent or volatile memory. Okay, so we're going to pop up a little poll here for the folk out there, and you can share your storage infrastructure technology right now, the kind of technology you have. And if you don't know what you have right now, you can pick that too. All right. So we got our answers, and it looks like a lot of folk have both hybrid and all flash arrays. So that's interesting. Great. Thanks much. So what is SCSI? Well, it's a very old set of standards that allows computers to communicate with peripheral devices. And SCSI is best known for use with storage devices like hard disk drives, but it can also connect to other devices such as tape drives, CD, DVD drives, scanners, and printers. And in terms of future protocols, NVMe or non-volatile memory express and NVMe over fabrics is slowly replacing the SCSI attach methodology or protocol for block devices. And SCSI came about in support of direct attached storage, but it persists in today by way of storage area network protocols, such as iSCSI and the fiber channel protocol. RAID, for those not in the know, stands for Redundant Array of Independent Disks. And it's a storage technology that stores data across multiple hard drives or solid state drives. And it can improve the performance and enhance the reliability of data storage. So it effectively makes a bunch of disks act like a more performant, reliable single device. And if a single hard drive fails in a RAID, your data integrity is still present, and you can rebuild your RAID with a replacement drive and bring it back up to full health. Erasure coding is a data protection technique that kind of breaks out data into chunks or parts and distributes it across multiple storage nodes. And this technology is quickly replacing the legacy RAID in a lot of storage systems. So we can classify storage in terms of the different media types, right? We've talked about flash, magnetic storage, hard disk drives, as well as optical. We could break it apart by saying, well, this is file storage, or this is block storage, or this is object storage. We could kind of classify it by locality. So this is primary storage, this is kind of secondary storage, and this is cloud storage. We could break it apart by attachment types, how it attaches to the compute. So whether it's direct attached to a server, it's network attached storage like a NAS, or it's a storage area network. So what's the difference between primary and secondary? So old school definition, primary storage was the volatile memory, the dynamic random access memory that was, in the server. And then the secondary storage was considered the disk or persistent storage. And that's not what I mean here by primary and secondary. So when I refer to primary storage, it's usually what your applications and your virtual machines use for their storage. And secondary storage, for the sake of this presentation, is usually used to keep backups or more non-critical data on. And it's typically, how do you compare it with primary storage? It's typically less expensive and it's slower than your primary storage technology. So what's direct attached storage? Well, that is a system that directly connects to a computer or server without using a data network. So it can be internal, DAS can be internal like a hard drive is within your laptop or your desktop computer or server, or it can be external like a shelf that connects to a server via serial attached SCSI cabling or SAS cabling. And to build on our auto parts store analogy, imagine that direct attached storage is similar to the back part of a store. So it's still part of the store, and thus the workers can quickly, get parts from it, return parts into it. So the DAS is like the back part of that store. So what's a SAN? That's a high-speed network that gives access to storage devices. So it's typically made up of storage devices, hosts, storage elements, and switches that are connected using different protocols, topologies, and technologies. So back to the auto parts store analogy, a SAN is to a DAS what a warehouse or a distribution center might be to a single store. So a warehouse allows the store to front end a far larger set of parts that it could keep locally inside the store. And if a store closes, the warehouse can still serve other stores. So that's kind of how a SAN is superior to a DAS. You can centralize a large amount of stuff that's available to many clients or systems. What's an HBA? Well, that's just a circuit board or an integrated circuit that connects a host system to a storage or a networking device. So an HBA could be a serial attached SCSI or a SAS-based card for direct attached storage, like a shelf, or it could be an Ethernet card or a fiber channel card for a storage area network attachment. What's fiber channel? So that's a high-speed data protocol that connects computer data storage to servers in storage area networks. It's primarily used in commercial data centers. And fiber channel over Ethernet is a computer network technology that allows fiber channel to use 10 gigabit Ethernet networks or higher speeds while preserving the fiber channel protocol. What's iSCSI? That's a SAN protocol, so it's storage area networking protocol that links data storage facilities, and it's based on the internet protocol, and it works on top of TCP. A storage switch, also known as a SAN switch, is a device that connects servers and storage devices. So SAN switches are at the core of most storage area networks. And those can be Ethernet or fiber channel, by the way. So what's a NAS? That is file storage device that allows multiple users to access data from a centralized disk capacity. So NAS systems are connected to a computer network through a network or an Ethernet port. NFS stands for Network File System. That's a networking protocol for distributed file sharing. It's one of several network attached storage distributed file system standards. What's CIFS or SMB? CIFS is a network protocol that allows users to share files and printers over a network. Microsoft introduced CIFS in 1996 as a dialect of SMB or server message block. And CIFS is an open cross-platform technology that's based on native file sharing protocols built into Microsoft Windows and other operating systems. We've got another poll. So now let's take a look at your virtual machines. Okay, it looks like we have almost a tie between fiber channel and vSAN or AOS technologies, and a good amount of folk on iSCSI. So it's pretty interesting. A lot of folk have hyperconverged. Cool. Thanks everybody for participating. All right. Data reduction and data duplication, deduplication and compression. So let's talk about those. So deduplication is a technique for eliminating duplicate copies of repeating data. So deduplication lowers your costs by reducing the overall amount of media required to meet your capacity. Compression is the process of encoding information using fewer bits than the original representation. So it's not like listening to an MP3, which is lossy, right? You know, the quality goes down a little bit on an MP3. Compression in enterprise data storage is lossless. And finally, data reduction is the generic term for any kind of methods of reducing the size of the original data so it can be represented in a smaller space. So it's a generic term for any kind of reduction, whether it's deduplication, compression, et cetera. All right, I think we're going to go past this question break here. And we're going to move into kind of the performance garage part of the presentation. So a little bit more advanced stuff. All the earlier stuff there is for the folk new to storage and whatnot. We're going to get into the more advanced technologies and techniques here. So for the newer folks, folk new to storage, bear with us. We'll get through it. All right. So how does this all come together here? Well, old video games didn't have save points. If your character died, you'd have to play the whole thing over from the start. And at some point, you know, things changed. You could save, you know, parts in the game. So a storage snapshot's like a point in time view of data in a computer system. It's a set of reference markers for data at a specific time, and it's similar to like a detailed table of contents. So clones are writable volumes that start off as copies of that snapshot. So, snapshot's a point in time image of a volume that reflects the state of the instance and the attached volumes at the time it was taken. And snapshots are read-only and can't be changed, whereas clones can be written to. So it becomes like a child, descendant of that original snapshot that it was cloned from. And here's Performance Garage tip number 1. If you are not leveraging snapshots on your primary storage to provide restore points for your data stores or your applications, regardless of what your backup or recovery system do, you probably should be. So replication or storage-based replication is a method of copying data to multiple storage locations, and it can be used to retrieve data and use it if the primary storage location fails. So tip number 2 here, if you have 2 or more storage arrays from the same vendor at 2 or more sites, and you're not already, consider replicating from array to array to provide some disaster recovery capabilities. And sometimes you can't because maybe one array is a different size than the other, but it's a really handy way of protecting yourself, especially in this day and age of ransomware, cyber attacks, etc. All right, we got another quick poll here. Snapshots, replication, who's using what? So we're going to pop that up. All right. So it looks like it's almost a tie between using snapshots but no replication, and snapshots and replications. That's great. That's really good to hear. These features are usually, no extra charge at this point in time from the storage vendors. So that is great. And thanks for participating in that poll. All right, immutable storage. So that's a set of features that prevents data from being edited, changed, or deleted for a set or an indefinite amount of time. And most primary storage vendors have immutable storage snapshots. Many secondary storage / backup and disaster recovery vendors have similar capabilities for their storage. All right, so Performance Garage, tip number 3. If your storage array has locking snapshots, and examples of this would be like NetApp SnapLock or Pure Storage's Safe Mode. If you're not using them yet, consider a plan to enable them moving forward. So just in case the storage array is compromised, when you have locking snapshots, they're still going to be capable of being retrieved. So it's another way to protect yourself. Object storage, also known as object-based storage, is a computer data storage architecture that stores and manages data in an unstructured format. So it's designed to handle large amounts of unstructured data, such as photos, videos, email, web pages, sensor data, and audio files. So the Performance Garage tip number 4 here is some primary and most secondary storage vendors will let you front end or archive to object storage, either on premises or up in the cloud. And that gives you a tool to save money and minimize an expensive capacity footprint on your primary or secondary storage. So that's kind of a newer practice that's come about. So what's around the corner? Object storage and the S3 protocol are actually pretty hot. Cloud storage, hybridization, and integration with on-premises storage, whether it's in the primary or your secondary storage, is getting popular. AI ML workloads are really quickly evolving the primary storage capability. So vendors are, doubling, CPU power, memory, basically kind of readying their solutions for these AI workloads that are going to beat up the storage real well. Cost optimized QLC flash arrays are quickly replacing disk-based and hybrid-based storage arrays. So that's, QLC storage technology is way more affordable, than the old TLC and the first generation of storage, flash storage technologies. Hyperconverged storage technologies such as open source based ones such as Ceph continue to gain popularity. And I'm surprised by the poll feedback. A lot of folk using vSAN and or Nutanix AOS out there. And NVMe over Fabrics will be more popular on the on-premises technology in time. It's a more efficient protocol than the old legacy SCSI technologies. Performance garage tip number 5. Define your problem first. When you're troubleshooting, define that problem. So have a person or a team formally state what the end goal is for your troubleshooting. And you can start monitoring kind of in 2 different ways. You can start from the bottom up, right? Start at the storage, then look at your network, and then the hypervisor compute, and then the guest VM sitting on top of that compute, and then the application. So that's bottom up troubleshooting. Or you can monitor from the top down. So, the application, which could be a database, it could be middleware, a web server, all the way down through the stack. So you basically can say, hey, database, what's your latency on this insert query, right? And then go down through the stack. So storage array vendors often have an integrated monitoring on a web portal or like a local command and control application. So when I say that, I'm talking about things like Pure One. NetApp have ActiveIQ Unified Manager. The Tintry arrays have, kind of built-in monitoring, and they can monitor through that stack. You can basically attach your vCenter or your hypervisor manager, whatever it is, SEVMM perhaps if you're on Hyper-V. You can basically monitor through that stack and get visibility through, those reporting and instrumentation portals that I mentioned. And for in-guest monitoring, if you're looking inside the VM, you can use perfmon on Windows, right? And if you're a SQL DBA or you have a relationship with your local SQL DBA, you can ask them to pull stats out from, sysstat or, within the database. And then for Linux machines, sysstat, iostat are good tools to use to kind of help you troubleshoot. So when you're in the guest, use the basic tools that come with the operating system to help out, to help troubleshoot. For hypervisor, ESXi hypervisor monitoring, the vSphere web client is pretty handy. You can go to the, click on a host and hit monitor. And similarly, there's metrics on the VM. And I'll add right here, I just thought of this right now. Click on your vCenter, go to configure, and make sure you have level 3 stats enabled throughout that. So you should see when you go to configure and advanced system settings on your vCenter, level 3 stats is what you want to get a lot of telemetry so that you can do monitoring with your vSphere web client. And so when you're doing that, you can look at physical uplink port contention. You can look at logical address or VM kernel overuse, right? Is it leaning on your iSCSI A fabric too much and not talking to the iSCSI B? What's going on there? And networks themselves have their own monitoring capabilities, and the storage arrays often have their own monitoring capabilities. So you have a lot of ways in which to leverage tools that usually don't cost any money. Maybe you just have to deploy them, right? You eat up a little bit of CPU and memory for local on-premises command and control applications, or you just log into a web page and you can look at the telemetry that your storage array is reporting back up to them. So you want to engage in all of these practices. But the most important thing by far, define that problem first. Make sure it's not, oh, well, this was slow at this time. Well, can you define how slow it was? Can you tell me which time it was? And then you'll have some evidence, or a lead to go track down and find out what's going on. All right, so let's talk about tuning. So performance garage tip number 6, minimize risk and be a minimalist. So what I mean by that is don't optimize everything at once unless you don't want to know what solved your issue or added performance, right? So tweak one variable at a time, really. Because if you solve the problem at one fell swoop, but you've touched a whole bunch of things, you might not know what fixed it, and you might want to know what fixed it for future deployments or configuration, conformity between sites. Always find a test workload before you apply changes to a production workload. So you can clone a workload for testing. You can clone an array volume or a configuration if you're testing out different block sizes or application profiles. So a lot of storage arrays will let you change a block size for a given application. Maybe you want, larger blocks for something like SQL Server. Maybe you want smaller blocks for something like, a VMFS file system, underneath your ESXi or vSphere, and see what kind of different application settings you might have on the storage array, either for the host initiator groups, if you're talking about like iSCSI, or for the volume itself might have its own profile settings. So make sure performance for one activity is impactful for performance on a similar activity. Conversely, make sure you don't harm performance for other critical activities. So if you alter the read ahead, right, for like a batch workload for like OLAP, then that might make your OLTP, or like a transactional workload, like little database transactions, it might make those suffer if you're altering, a parameter like read ahead. So you have to be sure that you're not harming things when you make those minor changes. You have to think the change through. And to that end, don't apply a change that's counterintuitive, um, because it might have consequences on those future workloads. So if you get better performance because you tweak this one thing, but that might cause a problem, for say the transactional workloads, maybe don't make that change, or test it really, extensively before you end up bringing it into production. And this is a really important tip. Not every change is worth enacting. So availability is just as important, if not more so, than just outright performance. So if you're at a junction between, hey, do I want to give up availability? Do I want to turn like, cache mode on or something, but the application, if it crashes, might not flush its data to disk. That kind of change, making that kind of change, make sure that risk is understood and bought into by, you managers, the application owners, etc. And finally, if in doubt when you're tuning something, ask a friend, a coworker, talk to your OEM. So storage security is really important right now, because storage is where data resides and your users and your applications interact with that data. So an effective security strategy can prevent unauthorized access to data and storage systems, and it can allow for fast restoration of systems when problems occur. So think about the snapshots that we talked about a little bit ago, or replication. So minimize the risk of data theft, prevent unauthorized disclosure of data, protect against tampering, prevent accidental corruption or destruction, ensure accountability and authenticity of the data, and ensure regulatory and legal compliance. So when you have your security on your storage, optimally set, it's going to do all of those things. And backup and disaster recovery is squarely at the intersection of security and storage. And these are just some of the examples of very deeply functional solutions that marry up or tie good security practices and novel feature sets into enterprise-grade storage technologies. All right, we're going to pop up a poll. So we hope you enjoyed the webinar. We're thinking about a deeper dive into the performance side of storage administration. There's a poll up to see if you'd like to attend such a class, and thanks in advance for your response. So looks like a lot of folk out there would be interested more. So great to hear. Thank you. And we appreciate you all, and thank you for attending today. If you're interested in learning more, reach out to your IVOXY account manager for personalized training engagements for your business or your department, and for future classes on lots of different availability topics. And we do have time for questions today. So there is no such thing as a silly question. Feel free to shoot them over if you have some.
So we do have a question from John. For replication, the concern is bandwidth. How do you determine bandwidth requirements?
That is a tough one. So the bandwidth that you're going to need can vary depending on the applications, right? And even the behavior of an application. If you measure at one time of the month uh, where you think you have a handle on how much change data is going on, you can look at the snapshot sizes and how they vary. But maybe your accounting department has a month-end processing that wasn't captured. So like anything in storage, you want to make sure you measure over the longest possible time and then figure out SLAs that will conform to your WAN link, right? Typically, your circuit is the limiting factor. And so you might just already have that WAN link up between your sites and you're limited to, okay, we've got a gigabit, link. What can we do with that? So you'll have to balance those change, the amount of change data that you have and the amount of points in time that you want to capture and how quick. What's your RPO? What's the point in time that you'd have to roll back to if one of your sites, had an unfortunate disaster incident or cyber attack or whatever. So the short answer is it depends, but there are ways of using your array UI to gather that information, to look at that delta and then conform it to the RPO and get things configured to meet the business requirements. All right, shy crowd today. Well, I really appreciate everyone's time. If you have further questions, feel free to reach out. And thank you so much for attending. And I hope you all have a great day.